Welcome to my projectbazaar.com.
Now we discuss about the product for data encoding technique for reducing energy consumption in network on chip. Next we see the abstract for the product. Nowadays the on-chip communication is relevant as and in some cases more relevant than the computation related issue. In fact of communication subsystem increasing the impact of traditional design objective include the cost, performance, power dissipation, energy consumption and reliability. As technology shrinks an even more significant fractional of the total power budget of the complex of many core system on chip is due to the communication subsystem. In this paper we focus on technique aimed at reducing the power dissipated by the network links. In fact of power dissipated by the network links as in the relevant as in that dissipated by router network interfaces, and their contribution is expected to increasing the technology scale. In a particular, we present a set of data encoding schemes operating the field level and the end-to-end basic, which allows the minimized both of switching activity and coupling switching activities on the link of reducing the path transferred by the packet by the proposed encoding scheme, which are transparent with respect to the router implementation and presented the discontinuous of algorithmic level of an architecture level. Assumed the means of simulation and synthesis the real traffic scenarios. This analysis takes into account the several aspects the metric of design including the NOC based architecture designs. This architecture designs technology shrinks the power dissipated from the NOC oriented IC designs for our architecture starts to compare the power dissipated by the other elements of the communication subsystem, namely the router and the network interface consider. In this paper, we present a set of data encoding scheme aimed to reducing the power dissipated link and the same as to the data decoding process. The encoding and decoding architecture to be designed for based on our base paper architecture designs and to reduce the power dissipation due to the encoding and decoding scheme in our total architecture process. The encoding and decoding architecture is to retrieve the correct data due to the data transmission in our NOC based architecture. So the modification process mainly focused for data encoding and decoding or internal architecture designs. Next we see the flow diagram for the product. First the input data bits are applied to our binary architecture designs. This the data encoding architecture to apply the binary data bits. This the pre-processing module to inverting the inverting logic for required input data bits. Thus the inverting output results are applied to the 1-bit sum function for the combinational sample architecture. This is the combinational architecture to consider the 1-bit sum function. Thus the inverting results and to apply the 1-bit sum function to output for our the combinational results. This the combination output results are applied to the majority logic functions. This majority logic function mainly based on 3-input majority logic architecture and to apply the Franklin logic. This Franklin logic to apply the reduce the Boolean equation and to reduce the number of gate pattern in our the majority architecture result. The Franklin logic modification to based on our majority logic Boolean equation modification. So we reduce the number of in gate patterns in our architecture results. Then this result majority results to apply the XOR gate functions. This XOR gate function to apply the half invert and full invert logical equations. This half invert full invert logical equation to based on our input data bits results and to invert the majority result. This the result to apply the XOR gate functions. This XOR gate function to consider the 5-gate architecture. This architecture to reduce the 4-gate architecture. This architecture modification mainly focused for hardware complexity optimization and to reduce the power consumption level. The power consumption level mainly focus for our the area for overall data encoding and decoding architecture. Then the XOR get result to apply the encoding result. This encoding result to pass the decoding architecture. Thus to decoding architecture to decode our the decoding process. This the decoding process mainly same process to for the encoding architecture. Finally, we see the output for the product. Just we run the Xilinx ISC project. Our project was developed in VHDL language and to use the structural modeling process in our architecture designs. Then to open the transmitter and receiver, two sections are placed in our architecture designs. The transmitter section and receiver section mainly used for select the transmitting section and the encoding architecture to select the simulation process to run the simulate behavioral model. Then to create the iSim project for project navigator using the simulation process. Thus process to run the what are the process to apply for binary data bits and to record encoding architecture results based on our NOC based encoding scheme process. Then to apply the binary data bits for our architecture. Then to run the time specified on the toolbar, just we encode the encoding data bits results. Thus to close the simulation process, then to select the receiver section and to run the simulate behavior model. The receiver section mainly used to decoding scheme architecture placed in our receiving architecture sections. Then to apply the record encode and decoding scheme process. Then to apply the binary bits in our decoding architecture. Then the relevant decoding results are applied to our architecture process. Then to implement our architecture designs. Then to select the implementation process and to select the view RTL schematic diagrammatic representation. Thus RTL diagram is used to what are the logical blocks placed in our record encoding and decoding architecture. And also view the technological schematic diagram. The technological schematic diagram is mainly used to represent see what are the logical blocks placed in our RTL diagrammatic representation. Then the technological diagram mainly used to what are the lookup table input and output wire connections, then buffer connectivity for our data encoding and decoding architecture results. Then go to the design summary process. The design summary process mainly used to synthesize the report for our architecture. This is our device utilization results. The device utilization mainly consider the what are the lookup table and flip-flop output pairs, then the bounded input-output sections, and to calculate the maximum path delay section for our record data encode and decoding process. The path delay time is 2.359 nanoseconds in our process. The processing time mainly based on our path delay time. What are the input and applied to the record encode and decoding scheme and to display the output for encode and decode results. Thus the result passing time to be display the maximum combination path delay for the timing summary results in our record data decode and encoding architecture results.